Welcome to Trinath Chemistry classes. In this video, I am going to discuss about intermediate first year chemistry topic, acids bases. In this acids bases topic, this is my sixth video. In this video, I am going to discuss about amphoteric nature of water. Amphoteric nature of water. Thank you for watching Trinath Chemistry classes. Please like the video, share and subscribe the channel. According to Bronsted-Lowry theory, Lowry theory of acids bases, proton donor is an acid, and proton acceptor is a base. So according to Bronsted-Lowry theory, we know that proton donor is an acid, and proton acceptor is a base. So let me take an example. For example, here when H2O is water is treating with HCl. So it is accepting a proton from HCl and it is acting as a base. H3O plus and Cl minus. So here water is behaving as well as acid as well as base. That's why we can say that water has amphoteric nature. What amphoteric nature? Water has amphoteric nature, right? Water has amphoteric nature. That is, it is acting as acid as well as base. So the amphoteric nature of water can be explained with the help of this Bronsted-Lowry theory. So according to this Bronsted-Lowry theory, we know that proton donor is an acid, proton acceptor is a base. So if you take an example, the reaction of H2O, the reaction of H2O with HCl. So when HCl is dissolved in water, so it is acting as a base. As it donates protons, it is acting as an acid. As water accepts the proton from acids, such as HCl, it is acting as a base. Similarly, when it is interacting with ammonia-like substances, it is donating a proton to ammonia. It is acting as an acid. As ammonia accepts a proton from water, it is behaving like a acid. So in these two examples, what we can observe is when water is interacting with HCl, it is acting as a base. When water is interacting with ammonia, it is acting as an acid. So what we can conclude is water, when it is interacting with acids, it is behaving like a base. And when it is interacting with bases, it is behaving like a acid. That's why based on these two reactions, what we can say that water has amphoteric nature. It is behaving like acid as well as base. Moreover, it is behaving like either weak acid or weak base. Right? That's why what we can say that water has amphoteric nature. Suppose in IPE, Intermediate Public Examination, water is an amphoteric substance or water has amphoteric nature. Explain. Then what we have to write is, we have to take these two examples, and in the first example, water behaves like a base. In the second example, water behaves like an acid. Based on these two reactions, what we can conclude is water is an amphoteric substance. So in this one, I am also going to discuss about autoprotolysis of water. Autoprotolysis that is, it is nothing but self ionization of water. It is nothing but self ionization self-ionization of water. Autoprotolysis of water. Autoprotolysis of water. That is nothing but self-ionization of water. What is self-ionization of water? Here, when water it is liquid and when it is with another water molecule, what is happening is it is behaving like one water molecule is donating proton and another water molecule is accepting a proton. So the one which donates the proton is acting as an acid, and when this is acting as a base. This is acting as a base. And if you take the, I already mentioned water is a weak acid. That's why we are writing equilibrium. So if you take the reverse reaction, it is acting as a acid and it is acting as a base. So for our convenience, I am writing acid 1, acid 2, base 1, base 2. Base 1, base 2. Right? So this is corresponds to. Right? So this one we are calling it as the autoprotolysis or self-ionization of water. Autoprotolysis or self-ionization of water. Right? So this is regarding our amphoteric nature of water. Amphoteric nature of water. Thank you for watching Trinath chemistry classes. Please like the video, share and subscribe the channel.